Video, we are going to learn about what is merge sort and how merge sort works. Merge sort is a sorting algorithm that works by dividing an array into smaller subarrays, sorting each subarray, and then merging the sorted subarray back together to form the final sorted array. In simple terms, we can say that merge sort is a sorting algorithm that follows the divide and conquer approach, and it divides the array into two halves, sort each half, and then merge the sorted halves back together. This process is repeated until the entire array is sorted. Next, we are going to see how merge sort works. Coming to the code, we use this def keyword to define our merge sort function, and we took the input array as an argument. We use this if statement to check whether the length of the array is greater than 1 or not. Because if the length of the array is 0 or 1, then there is no need to sort the array. If the length of the array is greater than 1, as we discussed before, merge sort divides the array into two halves. For that, we use this length of array floor division 2 and assign it to R. Here we use floor division to get the integer value. After dividing the array into two subarrays, we assign left subarray to L and right subarray to M. For that, we use this slicing. Next, we recursively call L and M until the array has one item left. Let's see that in the working video. As we can see in the video, first the array is splitted into two parts equally by using this division formula, and then we recursively call this function left side and right side. Let's see that. As we can see here, the array is again splitted into subarrays. We recursively called L and M until only one item has left in the array. Here we can see 6 is one item in this 1, 5, 3, 2, 4. In the next line, we initialize I, J and K to 0 and use I as an index to iterate to the subarray L, and we use J as an index to iterate through the subarray M, and K is also used as an index to iterate through the original array, and we use these indexes during sorting and merging of the array. After that, we use the while loop, which is a control flow statement which repeatedly executes a block of code until the condition is satisfied, and its syntax is while and followed by a condition. Here in this condition, we are checking whether the index I is less than the length of the L and J is less than length of the M. And here and is a logical operator which is used to check if both conditions are logically true or not. If it is true only, then while loop begins. And this following block is the merge part of the merge sort array. Next, in the if statement, we simultaneously compare the elements at the correct index I and J. If L is smaller than the element in M, then the element L is pasted in the original array at index K, and I is then incremented. Otherwise, M is copied to the original array at index K and J is incremented. In both the cases, K is incremented to keep track of the position where the next element should be placed in the original array. Let's see this block of code in the animation. As we have discussed until now, if we consider this 6 as L and this part as M, if we go to this block of code, if 6 is less than 1, we are considering that. Here it is obvious, we can say that this condition is failed, this if condition is failed. So we are taking this else clause, we consider this as K, we are pasting 1 in K. Next, the condition is true, so we again go to this loop and we compare 6 and 5. As this case also fails, we again paste M, that is 5 here. And next, we cannot blindly paste 6 at the end of this. For this also we need to write the code. That's what this code is. If any of the remaining elements left from the subarray L, we copy them to the original array. This line describes it, and it is by incrementing the index only, because we need to paste it in the new cell. So we increment K, and if there is more elements, for example, if we consider other than 6, there is 7 also, we need to increment the index of I also to copy and paste it in the K. So we increment I also. By doing this, we can paste 6 at K. This case can be applied to M also. So we write the same code for M. This is the code. Next, we consider this as L and this as M, and we go through the same process until we get a sorted array. Let's see this in the animation video. We get a final sorted array, which is K. Here we get the final sorted array, that is 1, 2, 3, 4, 5, 6. After watching the video, don't feel you can write the code on your own and leave it. When the time comes to write the code, you may feel difficulty. So practice before you do it. For the practice, I am giving you the assignment. Comment the answers below. As we have discussed the code in the video, let's execute the code. As we can see, this came in the ascending order. You can change the inputs and try it for yourself.